Hey everyone, and welcome to Artificial Intelligence, Reinforcement Learning in Python. In this course, we are going to learn about an entirely new paradigm of machine learning and machine intelligence. Usually, when students come into machine learning, they have these grand ideas, like they want to build a robot that takes out the trash and does cartwheels. Then they realize machine learning is not quite like that. It's more along the lines of, here's a picture, now tell me what's in it. For example, is it a cat or is it a dog? In other words, maybe a little bland. Well, that's part of machine learning, but today, we know that AI is capable of so much more. Just a few years ago, AlphaGo beat a world champion in the strategy game of Go, something that the world's leading experts didn't think would happen until at least another decade. And since that time, the original design has been improved significantly. From AlphaGo to AlphaGo Zero to AlphaZero, new AIs don't even have to learn from playing with other humans. They can become superhuman simply playing against themselves. But AI doesn't stop at being superhuman in simple strategy games. AI has been performing at or better than human levels at video games. It started with classic video games such as Pong, Breakout, and Space Invaders. But reinforcement learning moves fast. We quickly discovered how to train AIs to play Super Mario and Doom, video games from the 90s. And not only that, more recently, the leading experts in the world, OpenAI and DeepMind, have created AIs that can master even newer and more complex games, such as Quake 3, Dota 2, and StarCraft 2. But reinforcement learning doesn't stop at video games. One of the great achievements of AI will be robot navigation in the real physical world. Walking is a task that most humans learn to do as infants. But our limitation is that when a new infant is born, he or she must learn to walk from scratch. And AI wouldn't have such a limitation, since it could just copy the walking program from an AI who already knows how to walk. In other words, an AI can build on previous discoveries much more easily than humans can. Today, our AIs are able to walk in worlds with simulated physics. But we are making progress in real-world physics too. What's amazing about this robot is that it learned from simulation and applied those teachings to the real world. Techniques such as simulation will accelerate AI because robots learning from simulations don't take any damage. They won't break and we won't need to build them again. All it takes is a computer. AI seems to follow the law of accelerating returns. In other words, what we are seeing is exponential growth and it's not going to stop. As a student of reinforcement learning, building the future is in your hands. Thanks for listening, and I'll see you in the next lecture.